Welcome to the course on advanced marine structures. I am Dr. Srinivas Chandrasekhar from IIT Madras. I will be the course coordinator for this course. This course comprises of interesting topics as we discussed here. The course title has got advanced in its title, and we say that we will talk about marine structures. So obviously we will discuss about some of the fundamental forms of various marine structures in this course. Now you may ask me that how the word advanced is associated with this particular course content. We will also talk about some new generation marine structures. So some part of the advancement comes from the new generation concept which we will discuss in this course. In addition to this, there are some classical and advanced studies which are required to understand the response behavior of marine structures. For example, in this course we will talk about the reliability of marine structures, reliability analysis is one of the advanced techniques of understanding performance of any existing structure. We will talk about fatigue and fracture damages caused to marine structures because of various sources. This is again another level of advancement which is not classically and conventionally discussed in other courses. So as you see here, this course will have 4 modules. I will discuss about these modules in the PPT few minutes from now. So as a summary, this course will have 4 modules. Module 1 will focus on different types of marine structures. Various environmental forces acting on marine structures. We will also talk about the ultimate load carrying capacity of members. We will also talk about plastic analysis in this case in module 1. So let us see the presentation outline for this lecture. So we will talk about the course objectives, we will talk about the course plan in this lecture. I will discuss the detailed syllabus for various modules as I just now hinted to you. We will also talk about many references and additional support materials which are required to understand this course in detail. We will talk about brief overview of different types of offshore structures in this lecture. Now let us quickly understand what are the course objectives of advanced marine structures course under the braces of NPTEL IIT Madras. We would like to introduce different structural forms of marine structures to the readers. We will also try to give a brief overview of ultimate load design principles and estimating plastic capacity of sections. We will talk about the methods to estimate the capacity of tubular joints under axial, flexural and torsional buckling, which are common load combinations of any members in marine structures. We will also discuss the fundamentals of impact analysis and its application examples to collision problems on marine structures. We will discuss briefly the fluid structure interaction, highlighting the flow induced vibration, which is one of the critical area in marine structural analysis and design. We will discuss introductory topics on reliability of marine structures, including first order second moment method and advanced first order second moment methods applicable to marine structures. We will also discuss the concepts of fatigue analysis and design of marine structures as one of the course objective. Most importantly, the focus will be on detailed explanation of the topics through many numerical examples, which will help you to understand the topics under coverage in detail. Let us quickly look at the course plan. How do we proceed with this course on advanced marine structures? The course, as I told you, shall be covered in 4 modules. Each module will be designed with few tutorial sheets. I request that you should sincerely complete them before attempting to read the successive module for better understanding. Additional reading material referred from research papers will also be suggested at the end of each module. So, one can read these resource material to achieve a better understanding of topics of the course covered in the lectures. In module 1, we will talk about ultimate load design techniques, the principles and factors affecting strength of members. We will talk about fundamentals of plastic analysis of sections, estimate of plastic capacity of beams and frames. We will talk about capacity estimate of tubular joints under axial, flexural and torsional buckling through some design examples. We will talk about fundamentals of impact analysis, looking at the application to collision problems on marine structures. In module 2, we will speak about fluid structure interaction, we will talk about flow through perforated members, and we will also introduce flow induced vibrations to the listeners. In module 3, we will talk about introduction concepts to reliability analysis of marine structures. We will talk about the concepts of reliability and various methods of reliability studies as applied to marine structures. We will talk about first order second moment methods and advanced first order second moment methods of reliability studies and examples applicable to marine structures. In module 4, we will talk about fatigue and fracture. We will talk about fatigue failure and the causes and solutions of fatigue failure as applicable to members on marine structures. We will also discuss cumulative fatigue damage models and fatigue analysis and design of marine structures as a part of the 4th module of this course. Ladies and gentlemen, as I told you, the course will be distributed in 4 modules. Each module will have different topics of interest as we discussed. Now, interestingly, there are many references cited in the website of NPTEL of this course. For the benefit of the readers, let me quickly highlight these references faster on the slides. There are different books and research papers, textbooks available in the open source literature, which I request that the audience should try to procure the original copies of these and try to read them parallelly as they follow this course. Probability concepts are very important, therefore, you try to study Ans and Tang's book on probability concepts. Talk about stochastic dynamics of marine structures by Arvind Neis and Todd Jamon. Benjamin and Cornell discuss probability statistics and decision for civil engineers, which is one of the very good book for engineering graduates to follow this course. There are good books on hydrodynamics of ocean structures as discussed by Chakrabarty, including the nonlinear methods. So, I urge you to follow these books as important references in addition to the books which I am showing now. There are different books available for construction techniques of offshore structures, introduction to offshore structures, design, fabrication and installation given by Graf. There are good books available which talks about introductory concepts of marine structures which you must understand. There are good books available on preliminary design study on exclusive compliant structures like TLPs. So, try to acquire and have access to these so that you understand the topics better on various structural forms of marine structures as you read these books. There are good books available on structural reliability, analysis and prediction by Melchers. So, I want you to understand the reliability concepts as applicable to marine structures following these books. Populus and Pillai is another book where people talk about probability and random variables applicable to stochastic process, which is important. Analysis and design of marine structures is a very important book available by Sadehi, which one can follow, whereas Sarkaya and Isaacson talks about the mechanics of wave force and offshore structures, where the fluid structure interaction is explained in a very nice manner. So, there are books available from my side, as I have co-authored with Nilanjan Shah one of the short term course what we organized in the IIT Madras on reliability of offshore structures. This is a priced publication. You can write to me to acquire a copy of these short term course notes available on reliability of offshore structures. There are books available talking about analysis and design of offshore structures with many illustrated examples, which is written by me and my colleague Professor S. K. Bhattacharya of IIT Madras, is available in the literature. So, I would request that you procure these books and try to read them parallelly as we proceed with the course. Now, interestingly, the fundamental question comes, before we understand different advancements happened in marine structures, let us look at the history, let us look at the origin from where these kinds of marine structures started off. Ladies and gentlemen, this portion of the lecture will have a common repetition of many kinds of courses which address offshore ocean structures and materials. So, this is mandatory because I wish the readers to understand these fundamentals at one go. Therefore, there is a small lapse of repetition of this part of the lecture, which you must have heard or you might have studied earlier on different kinds of offshore structures. Nevertheless, this is important because this will give you a full understanding of different evolution strategy of offshore structures from the prehistoric period to the advanced levels. Let us talk about the history of offshore industry. You can see the photograph taken on Huntington Beach in California way in 1900s, where you can see there are lot of offshore derricks which has been placed all along the coast where people have started exploring oil. It is interesting for you to understand that oil will be available or was available in 1900s at a very close depth of about 20 meters. So, people started using this kind of structures for exploring oil in the initial stage. We started off from 1900 in Huntington Beach in California, further which we can see the Summerland, California also showed off many derricks, which you can see here in a black and white photograph. Successively, different elemental production platforms were constructed. Essentially, you can see the truss type structure which has been constructed in the early stages. The structures look very simple, resting on 4 or 6 columns which are simply diagonally braced, and they were the structures required in the initial stage when the water depth of exploration was very shallow. You can see there are series of structures. So, offshore industry or the marine structures were not constructed in yesteryears. It has got a very old age historical development which we must understand to really realize how advancements took place in this industry. So, you can also see the lake Maracoiba in Venezuela, where complicated, tall, strong and stiff structures were constructed for greater water depths gradually. So, ladies and gentlemen, one can realize that the structural form started getting upgraded from a simple form to a complex geometry as the water depth of exploration started increasing from shallow to medium to deep, and today we are at ultra deep waters of oil exploration. Similarly, in Caspian Sea Soviet era, up to 100 kilometers offshore, you can see there are a lot of derricks constructed and an approach road has been made to transport the oil explored in these sites to an onshore area. Now the fundamental question comes, when did actually this industry begin? What was the origin of this industry? Interestingly, in 1891 the first oil well was drilled at Grand Lake St. Mary's, Ohio. Subsequently in 1896 the first submerged oil well in salt water were drilled in Summerland field extending under the Santa Barbara Channel in California. The simple structure which has been used for exploring oil in this specific channel was shown to you in the previous slide. In 1900 early submerged drilling activities started. They started occurring on the Lake Erie on the Canadian side. In 1910 Caddo Lake in Louisiana showed some exploration activities. In 1920 Lake Maracaibo in Venezuela started constructing concrete platforms for drilling or oil exploration. In 1923 one of the oldest subsea well recorded in the infields offshore in Bibi Aibat well in Azerbaijan was reported in the literature. In 1930 Texas company developed the first mobile still barges for drilling. So subsequently you will see that the historical development of marine structures started in 1895 and continued to grow. In 1937 the Pure Oil Company, which is now the part of Chevron Corporation, and Superior Oil Company, which is now the part of Exxon Mobil Corporation, used first a fixed platform to develop a field in about 4.2 meter water depth at 1 mile offshore near Louisiana. In 1946 the Magnolia Petroleum Company, which is now the part of Exxon Mobil, erected a drilling platform at a depth of 5.4 meter 18 miles off the coast in Louisiana again. In 1947 the Superior Oil Company, which is now the part of Exxon Mobil, erected a drilling production platform at a depth of as shallow as 6 meters in the same area for oil exploration. In 1947 the Kermaki Oil Industries, which is now the part of Anadarko Petroleum Corporation, and Phillips Petroleum, which is now the part of ConocoPhillips, and Stanhope Lynn Oil and Gas Company, which is now the part of BP, had completed the historic Ship Shoal Block 32 well in October 1947. So it is about 150 to 180 years down the line when the marine structures were started constructed because of specific purpose for which they have been built. So if you look at a brief summary of different kinds of platforms as on December 2012, we have in US in Gulf of Mexico approximately about 4,000 platforms, where in Asia we have got about 950 platforms, in Middle East, in Europe, Northeast and Northeast Atlantic and West African coast we have got about 700, 470 and 380 odd numbers, which has summarized the total number of platforms so far constructed around the world. All these are different types of marine structures constructed by various sources, various site specific regions for only one purpose, where people wanted to explore oil. Because of this they constructed different kinds of marine structures. Amongst this, the original evolution started from fixed type of offshore platforms or the marine type structures. Fixed type platforms actually has a base of the platform which is fixed to the sea. It is because of this reason the term associated fixed to that of the platform is seen in the literature. The structure is generally very stiff, considered to be a rigid type structure, therefore it has a tendency to attract more forces. The response to the lateral loads acting on the structure is relatively less because the structure is very stiff. It is an expensive structural system people realized that the cost involvement in this kind of structures proportionate to the water depth is very high. On the other hand, people never thought of carrying this kind of structural form to deeper waters, because as these structures are moved from shallow to deeper waters, the cost of the structural system seemed to be very expensive. They were popular at early stages of oil exploration, but now these kind of structures are practically obsolete, because we are talking about oil exploration in deeper and ultra deep waters, where fixed type platforms will become highly uneconomical. So, these kind of structures are mostly constructed in steel. Of course, you have got exceptions where people constructed them in concrete as well. About 148 platforms of fixed type were constructed around the world. You can see North America has 30, whereas Asia had, and Asia and Europe put together had lot of investment on the fixed type structures. Intelligently you could see that in North America people started moving from fixed type to other type of semi compliant type in earlier stages. Therefore, the initial investment in this kind of platforms constructed in North America were much lower than they have been invested in Asian and European sectors. Looking at the water depth as the fixed type platforms proportion, you will see that United States hosts about 13 of the 16 platforms which are fixed at a water depth greater than 200 meters, because you can see less than 100 meters there were 72 platforms, whereas as the water depth keeps on increasing, the number of fixed type platforms is on the declining side, because as you keep on increasing the water depth, the cost of construction, installation and exploration of using fixed type platforms at greater water depths becomes very expensive. For statistical information, let us try to understand what are the deepest and shallowest platforms constructed. The deepest platform is constructed at a depth of 412 meter, which is a Bullwinkle platform in Gulf of Mexico in United States, whereas the shallowest platform is constructed at just 13 meter depth, which is called LSP-1 in Russia. Let us quickly see the statistical information as applicable to Bullwinkle platform. This is a photograph of the Bullwinkle platform, which is a fixed type offshore structure is constructed for oil exploration, located in Manatee Field in Gulf of Mexico, about 260 kilometers southwest of New Orleans. The cost of this particular project is about 5×10⁸ US dollars, where we convert this into Indian rupee, this comes to around approximately 2500 crores as on today. This was constructed by Heerema Marine Contractors then in that year at a depth of 412 meters. The total height of the platform is about 529 meters, and constructed in 1988. It took about 3 years for constructing this platform during that period. The total weight of the topside structure is about 77,000 tons, made out of steel. It has a capacity of 59,000 BOPD. So, one will be interested to know what do we understand by BOPD. BOPD is defined as number of barrels per day. One barrel is approximately equal to 158.98 liters. In that case, 1 BPD will be about 50 tons a year, considering the production rate. And in the present price, you can imagine the revenue what one can earn from one platform is about $6 million US dollars per day. So, that is the strategical and very interesting part which one has to understand as an engineer. The revenue given by this kind of marine structures are phenomenally high. Therefore, these structures should be designed with an utmost care, with a good level of surveillance as well as good level of reliability and confidence applied to this design and analysis stage. Let us talk about another kind of platform, statistical information constructed in Pompano. This is the photograph of the Pompano platform, constructed at a depth of 393 meters. It is a 4-legged platform with 12 piled, 3 on each group, constructed in the year 1994, weighs about 38,000 tons. The production capacity of this platform is close to around 60,000 BOPD, which has got about 90 mmCFD of oil in case of its production rate. The another important interesting platform which refers in the literature is Hibernia gravity based structure, which is called Hibernia GBS. The photograph is shown on the right of the slide here. It is located in Canada at a water depth of about 80 meters. Now the difficulty with this kind of platform is that the concrete weight of this platform is around 6×10⁵ metric ton. So it is a phenomenally massive structure which rests on gravity, that is why this is called gravity based structure, constructed in the year 1997 with a production capacity of about 50,000 BOPD. The other interesting platform which is constructed in series is a Troll A platform. As you see here, Troll gas field is located off coast of Norway. In 1996 the platform actually constructed set a Guinness of World Record for the largest offshore gas platform then being constructed in the year of 1996. It costed about 2500 crores then at that time in Indian rupee. The water depth at which this platform is installed is about 303 meters. The total height of the platform, as you see here, is around 472 meters, and it has got about 2,45,000 metric cube of concrete as a volume of concrete put in this platform, and equivalently 1/10⁵ cubic meter of steel has been used to construct this kind of platform. You can see a very clear view of another picture of this platform as you see here in the slide. Now let us look at the summary of fixed type offshore platforms which are generally recommended and installed at a depth more than about 100 meters and close to around 350 meters. So starting from the evolution of shallow water depth in terms of 1025 feet at 1978, moved towards 1992 at a greater depth in Exxon where we got about 1200 feet. It means in the evolution stage of marine structures of this order, when you have got fixed type platforms, these kinds of platforms were never constructed or attempted to be constructed beyond a depth of, let us say, around 400 meters, because as the water depth of exploration keeps on increasing, the construction topography or the structural form which has been used or preferred for this kind of platforms as you see here are generally becoming very expensive. So people never attempted to construct these kind of platforms at a greater water depth, say beyond 400 meters, because they have understood that these kind of platforms becomes expensive as the oil exploration depth keeps on increasing beyond practically about 350 meters. This lecture has got interesting references. I want you to read these references in addition to what I quoted in the website of NPTEL. There are interesting topics covered in this lecture which has been acknowledged to these authors from these specific books. So I want you to look at these material for additional understanding on this specific lecture on the introduction to offshore structures, where we talked about introducing different kinds of marine structures with one variety what we call fixed type offshore platforms. So ladies and gentlemen, in the first lecture we discussed about the modules 1, 2, 3 and 4, the course outline, the lecture topics what we will be covering in these lectures, and we discussed about brief introduction on one of the type of marine structure which is used for oil exploration, which is fixed type platform. So what I want you to emphasize is the historical development of marine structures started very old from 1900s, and people have started still moving on innovative structural forms which we will discuss down the line in this lecture. We will talk about different advancements happening or happened in this trade of construction of marine structures in the recent times, and of course different analyses and design methodologies as applied to these kind of structures in detail through this course. Thank you very much.